between current and drift velocity we are going to do, and for that you need to understand again the method. Okay, so I'm starting with the method first and then we go for derivation. So in that case you have to take a conductor of certain length. Let's say L is the length of the conductor. This is actually an area of the conductor. This is an area of the conductor, and now we are connecting this conductor with wires and with battery. So we have a key as well. When we apply the battery, that means when we switch on the key, so when we switch on the key, what will happen? Current will start flowing through the conductor. So I is the current, so this is the direction of current. Now very important thing is, this is the drift velocity of the electron. This is the direction of drift. That means electrons will drift towards positive end of the conductor, and with the drift toward positive end of the conductor, they will cross the conductor with which velocity? Vd. So the simple thing is, Vd actually is the length upon time. This is the simple thing. Okay, this is the one relation. Now the second relation will be current. So you know already what is current, charge upon time. Is that okay? So these are the two equations which help us to create a relation between V and ID. Okay, from this, now you need to understand, if I put the value of time from the equation 1, if I write value of time is L upon Vd, distance upon speed, and current is charge upon time, and time is L upon Vd. So it is simple thing is Vd upon L. Is that okay? Is that okay? Actually this is the basic equation. Now but I want to elaborate this equation, because I don't want the answer in Q. I want to change this. So if you know this, you can change further. Is that okay? So this diagram you in the examination you will draw this diagram, but remember this part. Shit. So basic thing is the formula Vd, and Vd is length upon time, and the second is current is equals to charge upon time, and finally you will get, using these two, and you will get current is equals to charge into Vd divided by length. So this question, this is the method. If you know, this is the method. Now if you remember this part, you can drive the relation. Okay, let me just explain you how to drive or how to write in the examination. Okay, so diagram you can refer for the video, so you just go back and draw that diagram. So same diagram will be there, but I will write few things. Let a conductor having few things, just you need to write having length. So I will not write because it will take some time. So length, I'm not writing full thing. You just write down length of the conductor, and second is A is the area of cross section, So you can write like this, and N is the number density. This is number density of free electrons. So you can write of free electrons, and just Vd. What is Vd? Vd is the drift velocity, and what is the current? Current is the, well, it is the flowing, I is the current, and then you can write current is charge upon time. Okay, now I want to write charges. So charges, how I will write? I will write number of electrons. So I will write number of electrons multiply by charge on each electron divided by time. Is that okay? Now number of electron Number of electron will be number density into volume of the conductor. Please everyone remember, this is volume. This is volume of the conductor, and volume will be equal to area into length. This is simple mathematics. So we are revising, so that's why we are not explaining everything. So NV into E divide by time. So now go for another thing, that is N into, what is V? V is area into length into E upon time. And as I told you, what is time? Time is length upon drift velocity. So finally you can see NALE into VD divided by L, and finally the equation of current will be in terms of drift velocity is NEAVD. So please remember this. Ohm's law, and Ohm's law, if you want to state this principle, you just simply say whatever the current is flowing through a conductor is directly proportional to the potential difference applied across it. So whatever the potential we are applying, let's say V, and closing the key, will have a current I. So you can write I directly proportional to V, keeping temperature constant. So this is the simple definition you can write. As this equation, we want to write down this equation dimensionally correct, so we'll write down in that way. We can reverse it, and we will write down I into R, where R is the proportionality constant, and that constant will be V by I, and the name for that is resistance. Its unit is ohm. Resistance का unit क्या होता है? Ohm. 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 The symbol is, let me just draw again. This is the symbol for resistance. For I equal to R, that is the resistance. I want to change this equation in a form where I can relate resistance in terms of relaxation time, in terms of area, in terms of length. So let's do it. And how we will do it? Because we have only two equations right now, we will merge these equations to get that relation. Okay, so which are two are the equations? So these are the equations. NEAVD already done, relation between current and drift velocity. And the second is, this is the equation one we'll use, and the second one is VD equal to E. You can put minus, but we are writing in a magnitude, so we'll write directly over m into tau. So this is how we will have two equations. So let's start directly. So put the value of equation 2 in equation 1. So you can write from 1 and 2. So VD का value 2 में 1 में रख दीजिए. So then you can get one thing, that is E, capital E over m into tau. Okay, then you can write NE square A E over m into tau. Now the basic thing is, I don't want, because I want the equation in voltage. And here I have electric field. So is there any, now you need to think, is there any relation between electric field and potential difference? So yes, we have this V by L equation. So use that equation and write down the equation. The new equation will be V, and the new equation will be I equal to NE square A into V upon ML into tau. So now I just want to write this equation in form of V and I, so that I can compare and directly write the values. Okay, let me just write this. So now I have this. Can I write this V by I equal to, so just by cross multiplication we can get this V by I. You can pause the video and just check how I'm writing V over I equal to ML over NE square A into tau. A into tau, that tau must be downward. A into tau. Is that okay? Tau is the relaxation time. So can I write V over I equal to ML over NE square tau into A. Now, this term will be the resistance. Term will be the resistance. So I have a new formula now. I have a new formula for the resistance now, and that formula R will be equal to M over NE square tau into L over A. So please everyone remember this formula, because this will help you to solve many questions. So now we have another formula as well, rho over A. This is the basic formula for the resistance, and this rho is the resistivity. So resistivity of a material is equal to now rho equal to M upon Ne square into tau. Is that okay, everyone? Now these two equations will help us to discuss the variation of resistance with temperature as well. Let's see current density. What is current density? So actually charges are flowing through a conductor. That means they're crossing the area. So let's take a conductor whose cross section area is A. So this actually is cross sectional area. This one is cross sectional area A, and this is cross sectional area, and area is a vector quantity we already knew, and current is a scalar quantity. That is okay. Now let's say this is also an area which is crossed by the charges. So which is crossed by the charges. So current is crossing this area. That is perfectly okay. So this current per unit area will be current density. This is called current per unit area. Current flowing through per unit area is called current density, but actually it's a vector quantity. So take an example, electron is flowing in this direction. Take an example, current is flowing in this direction. This is the current, but our area is in the different direction. So let's say the area is in this direction. So this is the area, and this is the current direction. So area vector will be normal to this. This is area vector. They are having some angle theta in between. Now I want a component of this area along A cos theta, I can write, and one will be the perpendicular one. So this is A sine theta. So along the current we have current upon area, that is called A cos theta, which is current density. So can I write current here? Current will be J A cos theta. As you know, area and current density both are vector quantities. So I can write this J dot A. So please remember everyone, current density, as I told you, current upon area. So current is in ampere and area will be in meter square. So what is the unit, SI unit for this? So SI unit will be ampere per meter square. So this is the SI unit of the current density. Or please remember, this current density is a vector quantity. So they many a time they asked this question that which type of quantity it is. So it's a vector quantity. So students, once there was a question based on this topic, that is vector form of Ohm's law. Let's drive the form. Again we will do the same thing. We'll have the two equation, I equal to NEAVD, and VD is equals to E in magnitude. We are writing E into M into tau. Using these two equations, we will again go for an equation which will give the vector form of Ohm's law. Okay, so let's start with this again. Actually we have to reach there over there in that form only. So but this time I will keep this electric field as it is. So voltage actually a scalar quantity, so we need a vector quantity, so we'll keep vector quantity as it is. So let's put the value of VD here and get the relation I equal to NEA E over M into tau. The final equation will be NE square A over M into E and tau. Okay, let me write this I over A term now. So take this A into the denominator and you'll get I over A. So we are taking this A to this left side and we are getting I over A equal to NE square tau over M into E. This term will be the current density, so J will be the current density and it's a vector quantity, and this term actually is the reciprocal of this term. What is it? Earlier we have done this is called resistivity. So can I write 1 upon resistivity into E, or this term now becomes J equal to sigma. Now reciprocal of the resistivity will be the conductivity. So this term sigma is the conductivity. Now as two quantities are vectors, so we can put the vector sign as well. This is the vector form of Ohm's law.